Welcome. I just want to go over some of the block modifications that I will be doing to my M20. This is going to be a 3.1 liter. So it has an M54 B30 crank, 135 millimeter rods, and custom CP pistons. And they're 85 millimeter bore, and that's the basis of it. And what I need to do on this, because I'm planning on running a turbocharger with high boost pressure, is we're going to O-ring the block. So if you've ever seen it before, I've got a little kit here, but this is where you take O-ring wire and put it around every cylinder, and it sticks out about 10 thousandths out of the block and pushes up against the head gasket. And I plan to use a factory style head gasket, and then factory head gasket with stainless steel wire. You can do an MLS gasket with copper wire, or you can just do copper wire with a variety of different other copper style gaskets. If you use copper, it indents, and basically if you have to remove the cylinder head, you got to redo your wires. But if you need to take off the head for any reason and not have to machine it, you can reuse the stainless steel that we put in the block. So the M20, I did this on the M30, and you can just do individual rings because the bore centers are wide enough apart. But on the M20, there's not much space at all between the bores. So what you have to do, I don't know if you can see the scratch marks there from just testing, but you basically have to split the bores so that the cuts overlap each other. So this ring and this ring overlap each other right in the center. And you can see here, getting that set up, see if I can zoom in for you, getting that cutter set up so that it's right in the middle is kind of tricky. What I did is I just took a gauge here, set it up on the block, and I measured from the edge of the cutter, when the cutter is all the way to the bore, with like a straight edge. So if you take a straight edge like this, put it right up against the edge of the bore, and then move the blade so that it's touching the bore. I took that distance and used that as my reference, my datum here, and measured the bore thickness between here. It's 240 thousandths, and then split that in half, so 120 thousandths. And then I took the width of the blade, which is 35 thousandths, split that in half, which is 0.0175. And so I took half of the blade width out minus the half of the bore, so 120, or half of the thickness of this, to get the edge of the blade to be the correct distance from that bore. So each side of that 35 thousandths blade should be equally distant between here and here on both sides. Sorry, hopefully that makes sense. There's my cardboard math, but I did measure it, trying to do as precision of a job as possible. This isn't the most precise tool, but if you're careful with it, it can be a good tool. The next thing you need to do, there's other videos on this, so I won't go crazy into depth on it, but I'll show you how I do it. But basically, you have to set up 25 thousandths shims underneath each 4 of the posts. So you're basically bringing the tool up off of the deck 125 thousandths, and then you set your blade dropped all the way down to the deck. That means when you take out the shims and drop it down, this blade can cut 25 thousandths. So you do your first cut 25 thousandths deep, and then you do a 5 thousandths cut. So I have these little shims right here cut up that are 5 thousandths. What I did, for those who are wondering, is I just got long feeler gauges from McMaster Carr. So like this is a 5 thousandths. And then you just cut it up with some like precision cutters. Make sure you don't have any burrs or like the ends are curled up. And that just makes a few shims to go under the edge of the tool here. Yeah, it takes a minute. I pulled this whole tool apart and lubricated the threads with grease and the parts right here where they touch the cone in the center that adjusts it. So I'm doing my best to just try to make the best of this tool. It's not crazy precise, but if you tighten it up and you try to take some of the slack out of all the pieces, you can get it to be a little bit more precise. Anyway, that's just kind of the background on that. I just used some Sharpie. You can use like Dykem dye to mark it, and then you can kind of get a feel of where those are going to go just by gently turning this to scratch that surface. Not very much, but just enough. But anyway, I'll show that process. I'll show you how we cut it. And then I think in a previous video a very long time ago, I showed where you have to clearance the block ever so slightly for part of the crank. I can show that in a later part of this video. But the only other thing that I plan to do is take a die grinder with a burr and go into this oil port right here where it's just a really rough, abrupt edge that just kind of, the drill is like halfway through this material. And then we're just gonna go in there and smooth it out just so the oil flow doesn't hit this wall right here and then have to like go around. It's just a little bit smoother. So we're gonna do a little bit of help with that. It's not a huge mod, but everything helps in these situations with oiling. And then we'll flip it over and we'll show you some other stuff. But for now, let's just jump into this real quick and I'll kind of show you how I set that up. And yeah, we'll show you how it cuts. All right, so the shims without the tape, I had already set these up, just showing you as an example. I got this shimmed up to 25 thousandths, and we're gonna go ahead and make our first cut. I put some oil around this so it can actually spin, but you'll see right there, it's already starting to take a cut. This is much easier when it's not in a car. I've had to do the last one in a car and it was pain. But you can see it's already starting to take shape. You just want to go nice and smooth. Try not to get any chatter. It is a little bit hard to not chatter it, but just do your best. Usually when it starts to bite really well is when it wants to chatter if it goes too deep of a cut. So don't put too much pressure on it. Just like that, just nice and slow. Just like that. And you can go through and clean it up with a vacuum just to clean that up sometimes, but that's just kind of the beginning process. We'll keep going. All right, yeah, just go around, pick up all the shavings. It'll just help it go smoother. But yeah, now just continue your cut. And then every once in a while, you actually can touch up your tightness. Make sure it's still staying tight. And what will happen is when you get to the bottom of this cut, it'll just kind of spin around. You won't feel it biting anymore to cut. It'll just spin around on the pedestals, but it's about time to clean it up again. Okay, we're at the bottom of this cut and you can just spin it around and you won't feel it trying to bite or cut. Even if you put pressure, it doesn't really want to bite. So we know we're at the bottom of our cut. So that one's good. And we're actually, normally I would just, if we're doing rings, I would just go straight to the 5 thousandths cut, but this one we're gonna do the 25 thousandths cut on every bore, and then we'll go back and do the 5 thousandths cut. It'll just make it a little easier, just keep the tool set up once. All right, so pulled it out. You can see they intersect in the middle there. And basically what we're trying to do is just start here, come around, and then figure 8. One single piece all the way down to the end, and then the partial pieces, there's like half pieces that need to be put in for the center 4. But, yep, there you go. Now I just got to do it 4 more times. So here's just a little test fit of some of the copper wire. You can see it'll come around, switch over, if it'll focus, switch over, and then continue around, and then go around and around. Anyway, just testing it here, see how things are going, making sure the cut depths are the same and everything. It's looking good. So this is the first pass done on all the bores. And now we need to go do the 5/1000ths pass on all of them. So I'm gonna blow out all the dust and vacuum them off really good. And yeah, we'll go ahead and set this guy up for 5/1000ths cut depth. Now to set up the final cut, we just put the shims on each corner of the pedestals. You can see, make sure that it's nice and sat down all the way. Try to feel if there's like equal tension among all of these. Like this one, see that's a little loose and this one's a little tight. Just make sure you've pushed down so that you've got equal tension. And then you loosen up the blade right here. And then make sure you push down pressure here and here, and then go ahead and tighten up the Allen key. And it'll be set, ready for that next 5/1000ths cut. So we're almost to the end on the 5/1000ths cut. I wanted to see if I could get a little bit of a zoomed view for you, but you can see where the previous cut left a 5/1000ths lip. I don't know if you can see it, but right there where they intersect, you can see there's a bit of a lip. Yeah, you can see that shelf. So you can see it's doing its job, and the 5/1000ths cut hardly takes anything. You go around it like 5 times and it's pretty much cut. And then I just make sure to go back and forth over it a few times where it intersects, just make sure it's clean. And yeah, it's good to go. So just make sure everything's cleaned up. I usually clean the edges of these and the little dowels. I usually clean them up right before I drop this down in. And then, yeah, we're good to go, just like that. Righto, it's complete. You can see everything's cut. I just put a small piece of copper wire between 2 of the bores just to get an idea of how it's gonna fit. Everything's looking good. Just gently tapped it in just to see how it would go when we do the figure 8 that goes all the way through the block. So anyway, that's yeah, that's cutting the block and tapping these in. These are very tedious and difficult to get in. I don't think I'll show that in this video because I'm gonna jump over to modifying this, and then I'm gonna take a tap and tap all of the threaded areas in the block, including this water port back here. And then I may or may not do some oil drain back modifications. We'll just see what I can do, but for now we're just gonna work on that guy. Alrighty, got some dust extraction set up, and then carbide burr. So you can see right there, we're just gonna come in here nice and gentle and just blend this area in so there's not just a shelf that it hits. It's kind of hard to see from here, but the drill where this was bored through, it just left like a really heavy shelf right here. So we're just gonna blend it in, nothing too crazy, but hopefully it'll help in some way, at least for what it's worth, you know, a couple minutes with a die grinder while we've got the block apart. So we'll rip into it. So just a couple minutes with the die grinder, and we were really able to blend this in. You know, not a massive change, but that's better than hitting a wall and then gushing sideways or something like that. So you can see it's a nice smooth entry, and I radiused it along this side too, where the bit had like dug into the side. So it's nice and smooth. Anyway, I mean, that's just something simple that you can do if you have a minute and a die grinder. It doesn't take long at all. Just a nice radiused curve. All right, so far so good. This is what I was going to show you now that I've got it tipped up on its end. This is the only boss that I had to grind to clear the crank. So on the M54 crank, I think it was just this was the only piece on one of the counterweights that had come around and needed some clearancing. But it only needs like a millimeter or two of clearance. But anyway, this is the drain back from the cylinder head. It's actually not too bad. It has like a little bit of embossment here from something like a lettering and stuff, but it's not crazy sharp or anything. Actually, I might mess around with this just for a second because I've got everything out, but just looking for any other places where I can clean up flashing and stuff that would help with drain back, but honestly not seeing too much here. So yeah, I think that might conclude it of this section. We're going to keep doing more stuff as we build the engine, but thanks again for watching, and 3.1 liter M20 guys, hope you enjoyed this and found it useful. Thanks.